not start on that now, but functions and logarithms. Oh, I forgot this class doesn't get out at 45. This class gets out at 39.
I know.
Fail on my part. Oh well, we're gonna get through one of this we can. I'll do the physics problem tomorrow.
This class always goes so fast on Thursdays.
I think it's because I don't get up here as quickly, and I wanted to give you those tests and stuff back so you would have them, and just.
It was like that last year and we didn't have the fifth period. I think fifth period is always the shortest class on.
Yeah, I think so. Well, even this class, like fifth period every Thursday, I just feel like is a struggle because it's already a short day, and I don't know.
Yeah.
Okay. The first one's just say to determine if the function's 1-to-1. And so with that, they give us a little graph here, and I'm just roughly sketching what they give us. But it's that, and it's the graph of y equals 1 over x squared plus 1. And they want to know if this is 1-to-1 or not. All we do to determine if it's 1-to-1 is if we slide our pencil down this way, the horizontal line test versus the vertical line test. Vertical line test for if it's a function or not. Horizontal is if it's 1-to-1. And so this one is not going to be 1-to-1.
My pencil just covers up the whole thing.
How big did you write it?
What?
I said, how big did you draw it?
Not very big.
All right, determine whether the function has an inverse. So
I remember doing
y equals x squared plus 5x. So we swap x and y, solve for y, so I get x is equal to y squared plus 5y. And then you need to get y by itself, or like solve for y, and we can't. That's as far as it can go, so no inverse.
If it
Can
was
all
like,
of those be like that? All the inverse problems? Like no inverse?
if it was like there was no y squared and it was just like something plus 5 or like y plus 5y or something, could we take out a y?
Yes.
Okay. Because the reason that didn't work.
Or if it was just like, if originally it was just x squared plus 5,
Mhm.
then obviously we could solve for it and it would have been. But because it was in both pieces, and nothing could factor out and leave us with just that. So like with this one, 12, we've got y equals 2 to the 3 minus x. So when we swap our x and y, I'm going to write it as 2 to the 3 minus y, so I don't have to rewrite the whole thing in a second, is equal to x. Because now how am I going to be able to solve this? With a log. So log base 2 of x is equal to 3 minus y. So then I can subtract the 3. So negative 3 plus log base 2 of x equals negative y. Divide by the negative, so 3 minus log base 2 of x equals y, and that would be the inverse of that.
I missed when answers to problems were like x equals 3.
So I'm doing an algebra 1, and sometimes it just kills me, man. I'm like, I'm so bored.
I know.
It's like there's nothing.
I feel like I always expect it to like work out perfectly, and then when it doesn't, I'm like, oh.
Yeah. It's like,
And then sometimes you get used to it not working out like that, and then when it does, it's like,
Wow.
it's like, oh,
Gorgeous.
yeah.
well that happened.
All right, these ones say to find, I'm going to write this out because it's going to be a lot for me just to say. Find F inverse, then verify that F of F inverse, so the composite function of that, of x, is equal to F inverse of f of x is equal to x. I don't like this notation, but that's how they write it, which is why I'm writing it that way so you can see it. All this means is do f of f inverse needs to be equal to f inverse of f equal to x. So basically, when you smush the two functions together as a composite, they need to both come out to be equal to just x.
Okay, that makes more sense.
Not gonna lie, it looks like FOF.
Well, normally it's a g, so I just say fog. But
FOF.
f of g of whatever, but this is f of inverse.
F of inverse of it.
FOF -1.
So 16, we have f of x equals x squared plus 1, and they tell us that x is greater than or equal to 0. I mean, that they're more just putting a restriction on it, but that problem, no. I was going to say, ultimately there could be a problem. No? No. I don't know. They're just putting a restriction on it, but obviously this isn't like a square root function or something, so it doesn't matter, but. So swap x and y, so x equals y squared plus 1. Y squared equals x minus 1. So y equals, and obviously plus or minus, this is why I think they're doing it. But we need the positive one, so we're just going to do the positive x minus 1. Ultimately, I think both of them are going to work the same because when you plug it back in, it's just going to square it, so it's not going to matter. So that's the first part. So then they want us to verify this. So I'm plugging, this is f inverse here, so I'm going to plug that in up here. So square root of x minus 1 squared plus 1 is x minus 1 plus 1, which is x. So that part's good. Then the reverse, plug this in here. Square root of x squared plus 1 minus 1 equals the square root of x squared, which equals x. So we're good.
So if one of them is correct, then
I would say at least 98% of the time they're both going to be right, but the book specifically wants us to check both.
so like just so we have practice going both ways.
Pretty much, yeah. There are very rare times where one may look like it works and it not, just conveniently, but it just depends. Are y'all okay with finding the inverse and like plugging it back in?
Yeah.
Okay. Since the bell's about to ring, do y'all want me to go ahead and give you some problems so that you have them, or do you want to just wait till we finish the last couple problems tomorrow?
I can wait.
Yeah.
Okay.
Because then if I have them, I feel like I'll need to do it.
Yeah,
That's fine.
we feel obligated to do them and then
It's basically just going to be a couple odd ones out of what we just did, and then we're doing problem 34, 38, and 48 tomorrow.
Okay.
what about like neither ones?
We'll see. I may go ahead and start. Hello. I may go ahead and start 1.6 tomorrow, as well, and then Tuesday can just be like a work day, so that way, because I don't even know how much of class I'm going to be here for on Tuesday. I know you're not going to be here, but that way you're not missing anything, and he has something to do and all the things.